This is a Lambda LH 130 FM-2414 power supply. It's a linear power supply, and I don't have any information on it. Lambda's kind of stingy about giving information out. I know I've fixed some of their supplies in the past, and getting schematics was pretty tough. I was able to find some schematics for a couple of the supplies I had, but this one I haven't had any luck. But anyway, looking at the front here, it's got a DC voltmeter that goes up to 120 and a DC ammeter that goes up to 500 milliamps. 500 milliamps. And it's got pots on the front here. They feel like 10-turn pots, which is good, although these feel kind of crusty to me. I don't know, that could be a problem. These 10-turn pots, basically they have a resistive elements, a small little coil, and it's wound in a helix, and then the pickup, as you turn the control, that pickup rides on that little helix and varies the resistance, and that's how you get the 10 turns. So the guy I got this from didn't know if it worked or not, so we'll check it out and see what we can find. So stand by for that. Here's the back of the unit here. It has a terminal on the back that you can configure for if you want to use remote sensing. It shows you how to do that, which is nice. It does say, see the instruction manual for series or parallel operation. Doesn't do me any good. I don't have the manual, so we'll have to kind of fly by the seat of our pants here. Looks like it's set up here 3 and 4, 4 and 6, and then it shows minus and plus DC, so obviously the load is connected internally here. So this is with a strapping on 3 and 4, 6 and 7, it's set up for local sensing. So on the right you can see if you wanted to remote sense if you're running a heavier current or a longer line. This is a pretty low current device, so it only goes up to 500 mils. And to test it, I have some power resistors here. These are 50 ohm 200 watt resistors, so by using these in series I can get 200 ohm load, and these are 200 watt, so they're pretty beefy. So the next thing I'm going to do is I'll set it up and we'll see if we get any output on it and go from there. So stand by. I have 450 ohm 200 watt resistors in series to give me 200 ohm load. I have a voltmeter across the output, and I have an ammeter in series with the load. So I'm going to turn on the supply. I've set the current adjust to max, and I'm going to bring up the voltage slowly, and we'll watch and see what happens. So I want to see if the current corresponds with this accurate meter, and if the voltage on this meter corresponds with a Simpson here. So we'll see what happens. I'll bring it up slow. Yeah, we gotta see the voltage. See if it drops again. It's got some bad spots on the pot here. There, it dropped again. It dropped down to about 12 volts. Now it jumped up to about 25 volts. Now it dropped down again. Yeah, it's all over the place. Well, 200 ohms at 100 volts would be about 500 milliamps. I'll have to change scales here. And bring it up slow. Yeah, this is... Okay, there's 500 milliamps on this meter, and we got full scale here, about 500 milliamps, just under 100 volts. And we've got, okay, I want to crank it down here. We're kind of at the limit. So now I'm going to leave the voltage, let's see, I'll leave the voltage about here. I'm going to vary the current adjust and see if that's more linear. It's on full scale here, or it's on full clockwise. I'm going to slowly bring it down and watch what happens to the current. I want to see if this pot is as bad as the other one here. It should start to come down. There we go. What I want to see is if it starts jumping or dropping out. Okay, the current pot seems to be okay. Let's try going up. As I bring it up, it's steadily rising here. It's not jumping all over the place like the voltmeter did. So I'm going to bring the voltage. Yeah, see, I touch the voltage and it's jumping. Jumps up and down. So this pot's got a problem with it. Anyway, I'm going to open the unit up and I'm going to try to take some measurements. Maybe I can open that pot up and clean it. It's a 10-turn pot. They can be taken apart. Sometimes you have to, you almost destroy them in the process, but I have been able to take them apart sometimes and clean them if it's not worn out. If not, I'll just replace it. I got a lot of 10-turn old Burns, new old stock Burns 10-turn pots, so that's probably what's in here. I don't know what the resistance is, but anyway, I'm going to open up the unit and we'll see what we find. 3 flathead screws on each side and the hood comes off. And here's the inside. This thing's built like a tank. Got your main power transformer, rectifiers, here's a filter cap, you got another cap back here. Your power transistors, your pass transistors are on some pretty hefty blocks here with a heat sink along here. Got a fuse here. On the other side, you've got your control circuitry here, calibration pots. I imagine some of these caps are getting pretty old here. I'll check and see if they're any good. Surprisingly, some of these old supplies are still pretty good. I know I've got a Tektronix curve tracer that has original capacitors in it, and it's almost as old as me. Well, maybe not quite that old, but still works good. I'll check this cap and this cap mainly. But anyway, here's the voltage control pot here. It's a Burns, which is, I think, the best 10-turn pot. So I'm going to check this out. I have a feeling this has got a problem with it. It wouldn't hurt to change some of these caps, I'm sure. I'll test them with the LCR meter though. Well, this is kind of a pleasure to work on. Just a few screws here on the top. 2 of them on the top. One was missing on the side, so someone's been in here, and this will tilt down, exposing the goodies here. Here's the voltage pot and the current pot. I noticed some corrosion on the meter terminals too. I'll have to look at that. Look at these nice wiring harnesses. Try to build something like that nowadays. These are General Electric meters, looks like. I think I'll pull this pot out, see if I can take it apart and clean it. It may be worn out. I got a bunch of these things down in one of the buildings there. They're new old stock, so it may be best to replace this. I don't know what the resistance is. 24K. Ooh, I don't know. That one might be a little tough to find. I may be able to take this apart. I think I took one of these apart a long time ago. I can't remember. I'll have to experiment with it. Anyway, that'll be the next step here. See if we can either get a new pot or fix that one. So stand by for that. Here's the pot. I removed it from the circuit. Hooked it up to an ohm meter. I've got it on 0 ohms. So I'm going to slowly rotate this and watch the meter. Yeah, it's jumping all over the place. Might be worn out. There's a 24K pot, so it should end up over here, just above 20. Yeah, about 24K. So I'm going to take it back down slow. Yeah, this is not going to work. And there's 0. It's a Burns trim pot. They've got terminals 1 and 2 shorted, and then they're using it as a rheostat basically between the wiper and here. And the problem is the wiper, so I guess I'm going to try to take this apart. I don't know if I can do it without destroying it. If I can't, I'll look in my stock for a 24K pot or similar. This is, I might have some bigger ones, but I don't think they'll fit in here. Yeah, this is a 5% linear taper. So, anyway, that's will be the next step. Here's the pot. What I did is I took a utility blade, and this is either glued or some kind of ultrasonic welded, this end cap on the end, and I slowly pried very carefully, and I was able to remove the end cap. Here you can see, as you rotate, contact is made between this piece of brass and this rotating in here. Now there's also, as you rotate it, I don't know if you can see it, but down inside here, as you rotate it, there's a shoe that rides on this coil. This is a coil of resistance wires. It's like a helix. It goes all the way down the barrel here, and then as you rotate it, that rides up that helix, and then it's conducted out through this piece of brass into the end here. So what I think I'll do, I might be able to get some cleaner in there, and also I can clean this brass surface. I'll put it back together and we'll see if we get a better variance of resistance here without the jumps. So it could be worn out, but then again it could be some type of corrosion on it. I don't know. It's real fine wire on these resistances here. These are really nice. Anyway, I'm going to clean that, put it back together, and then we'll see if we have any better luck with that. If not, I'll go down and see if I can find a substitute. So stand by. Well, I'll have to go to plan B. Took this thing apart, and here's what I found. It's actually broken. If I can get the piece out here. Part of the guide's broken, so that's why it wasn't making contact. So this pot is definitely no good. So what I'll have to do is I'll try to find a substitute, and then we'll go from there. And I need a 10-turn pot. It's a 24K, so hopefully I've got some. I've got a bunch of these down in my building, so I'll go look for that, and then I will be back, so stand by. Okay, this is what I need. Hopefully it's in here. Got a lot of these, but they won't do me much good. Really nice though. Anyway, nothing in there. There's a 2K, I had a 50K. Some of them are just too long. Let's see what's in here. This might have some possibilities. Let's see what I got under here. Oh. No, these are all big ones. Who made these? Borg. Helipot. 10K. Yeah, most of these are too big. My only... Let's see what this one is. 200 ohms, no good. I'll go through these and be back. I don't know. A lot of 2, 10, 50Ks, but no 24Ks. So we'll keep looking and I'll be back. I found a 20K 10-turn pot, a Burns, and it fits. I had one that was too big, so I had to go with this one. It's a little bit shorter resistance, a little smaller. It's not 24, it's 20K, but I think it's going to work. I'm going to turn it on. Okay, I'm going to watch the meter in the back here as I bring up the voltage here. And it should rise fairly steadily. And this one should match it here. You see, I'm not getting the jerky movements I had with the other pot. It would jump up and down when it would hit a bad spot. So I think that's going to work. There's 80 volts. Here's 100 volts, so that's working. So now I'm going to hook the load up. This will be the same 200 ohm, 200 watt load I had before. Now I'm going to start bringing the voltage up slow, and we should see the current start to rise. And it's doing it. Okay. We'll stop at 300 milliamps for now. There's 300 milliamps and about 60 volts, I'd say. So I think this is going to work. A little bit change in resistance, but the circuit's allowing me to get away with it. And once again, this was the bad part here. You know, you could feel it had something mechanical problem with it, and then once I took it apart, I found out the guide was broken here that it rides around in. You can see. Anyway, that new pot works. So I'm going to finish this one. I'm going to cook this one for a while, make sure everything's all right, and I may replace some caps. I'll check them, but I don't replace caps just to replace them. If they're bad, I replace them. That's it for this one. I hope you enjoyed it. See you in the next one. Bye for now.